Welcome back to the Astro Imaging channel. This is Alex, and I'm here with Hamza. Hamza Touhami is here today to tell us about Prism. He's going to give us a global overview of that, and we should have a good time listening to all of that stuff. I want to take you through a few things here. Let me share my screen. I got some hang-ups on it there. Okay, that's what we get to look at here. And I don't know where Tolga is tonight. He's probably having some kind of fun to everybody. And I'm going to go to our Astro Imaging site, testing the Astro Imaging channel. Here we go. And I'm going to click on the workshop because the workshop's what we're going to be doing next week. You should be seeing our imaging workshop page from the Astro Imaging channel. And you can see that Terry Robeson contributed some data. We've got 3 shots so far, and we would like to ask a general question. The last time we had, I think, 14 people responded to an M42. And here we have 3 people so far. It does say that you should get in your images by July 7th tonight. If you don't happen to, if you've got one ready to come in, hey, send it in anyway, and we'll try to get you in. The reason we would like to have you in by now is that you can practice your making sure your telescope or your software and everything is working. So at any rate, please go ahead and send in your data on NGC 1968. To get there, you can go to this link right here, and then go to the link to get the data. This is the data link, and you can see the past stuff here. Okay. Also, I want to show you some upcoming shows. Today, Hamza is going to be here, and he's changed from to be announced to a general overview of Prism software. And then next week, we'll have that at least 3 or 4 people come in and show us how they processed that NGC 1968. Bill Lee's coming up to show us about free and low-cost software, and then TJ Connolly, who's a really good solar imager, is going to tell us about how to get ready for the Mercury solar transit. Hamza's going to be back a couple of more times, and he's changed these to, and he could probably tell you a little bit about tonight what he's going to be doing in later shows. Richard Wright's going to be here. He's always popular. He writes for Sky and Tel, works for Software Bisque, so teaches at a community college down in Florida, and in general is an all-around good guy. We want to remind you also that there will be an imaging workshop for our friends Warren Keller and Ron Betcher, both of whom have been on the programs before here at the Astro Imaging channel. They're going to be in Chicagoland. It's coming up. So you want to get over to their website over there and figure out what's happening with that. Get in on it. It's really a good thing to show. Okay, that's enough for me. And Hamza's here. Hamza's ready to go. Hamza, can you take over?
Yes, absolutely I can. Thanks for the invite.
Okay, go ahead. You got it.
Hello. Good evening to all. Everyone in the room and everyone watching. My name is Hamza Touhami. I'm here today to speak to you about Prism. There has been another show where another gentleman by the name of Bob Sandness did a presentation before, and I'm here to revisit. I'd like to talk to you a little more about what Prism does, and this today is a general overview of all the fun functions it has and all the power it packs. So here we go. So I'd like to start with this image, this beautiful image taken by Laurent Bernasconi and Michel Meunier using Prism. And this was entirely captured, automated with Prism, pre-processed with Prism, and processed with Photoshop CS6, I believe. It's a beautiful rendition of these targets. This was shot with a 20-inch Newtonian f4. And a fun fact, these gentlemen shoot with an ASI 1600 camera and a 20-inch f4 Newtonian. So if you have that camera, it can deliver. So session number 1 today is a global overview. I would like to do a little introduction, talk to you about Prism, myself, a little bit about the astronomers' challenges. This is professional or amateurs. Why I'm talking to you about Prism version 10 and an overview of the functions and all the fun features it packs. So Prism is a fully featured astronomy software that includes planning, capture, automation, processing, and analysis. It's a one-stop shop. It's been created in 1995 by Dr. Cyril Cavadori to perform CCD testing at the VLT, where he was a CCD engineer. So Prism was used for a lot of advanced functions like CCD characterization, dark current, red current, and so on. It has an extensive tool set focused on ease of use and power. So basically, the mission behind Prism is to give you the most amount of power and make it a package that is easy to use. We would like it to be one toolbox that you could use for all your astronomical endeavors. It's everything under one hood. It's from planning all the way to publishing. You could use it to plan, capture, process, pre-process, post-process, do your scientific analysis, and so on. So a little bit about myself, so you know who's behind the veil, as we say. My name is Hamza Touhami. I live in Phoenix, Arizona, with my beautiful wife, Nicole, and 2 children, Amir and Silas. I'm a construction project manager by day and an avid astronomer by night. I created Hyperion Astronomy in 2017 to support Prism worldwide and succeed Prism America. This is the outfit that was before me and did a fantastic job in the promotion and the support of Prism. I don't have a equipment myself here locally in Phoenix because it's a white zone and you have to travel 100 miles in each direction to reach an orange zone. So I operate my telescopes that are both in southern Arizona, hosted with remote observatories, and another one that we just started with Deep Sky Chile with Frank and Cedric. This is right next to Cerro Tololo. It's not very far, and it's about southeast, I believe, about an hour southeast of Ovalle in Chile. All the images, all the NEO studies we do are coming out of these 2 systems. So I would like to talk about some astronomer challenges that we could think of immediately. The amateur astronomers and sometimes professionals as well are faced with some common challenges. One is too many programs to learn, guiding, focusing, plate solving, stacking, process, and what have you. Analysis software can be very daunting and very hard to use. And a lot of these, I should say, some of these programs were created by a community of developers, and sometimes it's hard to find literature because all the people using it are very familiar with it. Too many programs to update. Well, sometimes you have 5, 6 pieces of software that are on a computer somewhere remotely or in the backyard, and believe it or not, sometimes updates can be very problematic. Some of these software packages are developed by different people, and when they decide to update, more often than not, there's no correlation with other packages. Sometimes update do break given links between packages, and the astronomers left wondering, do I go backwards? Do I downgrade? Do I delete and reinstall? What do I do? Sometimes it's hard to juggle all of it, especially on smaller screens. Imagine having a sky chart and a capture software, and you're focusing going on one side and your plate solving going on the other. It could be a challenge. We've all been through it, coming up through the ranks. Multiple support avenues to seek. Well, multiple pieces of software, naturally multiple developers, hence multiple email addresses, multiple forums. It could be a little bit tedious. And something we notice is the lack of multimedia tutorials on the internet. This is especially true nowadays that YouTube is a mega place to have all sorts of YouTube of video materials and blog posts, written tutorials. Sometimes there's a lack of multimedia. There's just a user manual and sometimes a forum behind it. But is there more to this? Can somebody provide more avenues that are easy such as video tutorials or just a blog post that's written about one thing. So why is Prism different? It's a true one-stop shop, a single program to learn, update, use, and one support channel to seek. So when we say a true one-stop shop, it virtually does everything for you in any of your astronomical needs. It's easy to set up and operate. You can set it up once and done. There are facilities inside Prism to where you can save all your settings, and it's repeatable night after night. This is especially great when you have no time to waste with setting up and resetting up and all these tedious steps, especially when your skies do not permit nightly imaging. Sometimes people don't see stars in 2 months. This happens. And this is one of the reasons, by the way, quick note, is why we push our trial to 80 days, is to accommodate for these people that are unfortunate enough to not see stars in 2 months. No external software needed. Prism has everything built in, including a sky chart, automation, autofocus, auto-guiding, plate solving, etc. Everything is under one hood, compacted in one screen. So if you need something, it's more than likely there. And another note to this effect is where we listen. Prism is evolving and evolves quickly and very often. So there are updates multiple times a year to bring in new features people ask for and bug fixes and so on. Scientific analysis. Some of the most powerful functions are built into Prism that you will find in professional observatories. Example, the Very Large Telescope for CCD characterization. So this will be a whole theme. This will be the third session, as Alex pointed out, that I will set the themes for these sessions that are upcoming. The third session, which will be September, I believe, will be about the advanced functions in Prism. This, in all its worth, needs its own session. There's a lot inside Prism that is very advanced, very specific, that professional astronomers actually use. Less hassle, inter-software communication. Prism reduces the rate of failure that happens between multiple pieces of software. This could be a Windows update. This could be programs updating, breaking links to other programs, and so on. Prism reduces the risk, especially for remote systems. There's no inter-software communication. We do it all in one package. And naturally, it's backed up by Hyperion Astronomy. We provide support through phone, email, forum, and downloadable materials. We have a lot of it. We even offer data sets to our customers. We're coming up with a new customer area where we actually provide data sets so people can practice these tutorials that we give them. I have published over 35 video tutorials since we started the company, and I figured I have about 100 more to go. And what I believe is that to give the customer as much information as possible in a way that is very direct, very personal, and we figured that video tutorials are the best way to do this. I make one video tutorial very specific to one subject, and sometimes it's less than 2 minutes, and very extensive videos are over an hour. We can always go through backwards and forwards in the video, so length is sometimes a good thing. The automation video was an hour long, but I know we're all busy, so more often than not, it's less than 2 minutes. Alex, are there any questions so far?
No, we're doing fine over here. Eric's monitoring YouTube over there.
There are a couple of questions. I don't know if you want to get to them now. There was one question about using Linux. I assume you're going to get to operating systems. And the second one, does this use ASCOM?
Yeah, absolutely. It does use ASCOM. Anything that has ASCOM, and I'm going to get to it. A lot of it is built in that they're natively supported inside Prism. Very good question. Does it work on Linux? Well, I'm going to tell you the broad statement of not yet. We don't know which way this is going to pan out, but today it's a Windows-only platform because of all the hardware support available. I hope that answered it.
Okay, Eric? Okay, I should remind you that we would prefer if you would go to the YouTube area and be watching over there on the YouTube and follow along in the YouTube chats area. There are people over in Rumble Talk, and there are a few friends got together and said hi to each other, but we don't have any questions yet, and that's fine. But the advantage of going into the YouTube Talk area is that you can make comments, and those comments will stay with the program for the life of the YouTube program. And you can just follow along over there. Okay, so we're going to turn our mics back off and turn it back to Hamza.
Thank you. So here's an image of NGC 1532. This was also captured and pre-processed with Prism and processing with Photoshop. I'm showing you these images because they're beautiful, number one, and they're very attainable. When you have good data, processing becomes a lot of fun. Some of us sometimes spend a great deal of time dealing with defects, but this is a 20-inch f4 Newtonian. And if you have an ASI 1600 camera, this is what it can do. This is what it was taken with. But we take pride in saying this was completely planned, captured, automated, and pre-processed in Prism and processed in Photoshop. It's a beautiful image. Moving on. So I'll talk to you today's session about an overview of the features and the functions. This session is designed to just gloss over all the goodies inside Prism, and the next session will be about planning, capturing, automation, and processing, and the third session will be about all the analytical power that Prism packs. A sky chart. Of course, it has a sky chart. It's very, very powerful. It includes some advanced functions in here as well. It has extensive catalogs, some star catalogs. Locally, we installed GSC-ACT with Prism, but you could download from our website, the USNO, UCAC, and we pack the photometric calibration stars. And as of late, we included a Gaia DR2 Grappa local version that we support, but one has to be careful here. It's about a 70 gigabyte download, so it's not small, but we support it if you need it, and you can have it locally. We also support online catalogs such as the Gaia DR1, the DR2 Grappa again, if you feel like you should download them for the field you're imaging and don't need any local massive catalog. PPM-XL and Nomad. For the deep sky, you can display the Messiers, the NGCs, the ICs, the Abels, MGCs, and so on. The list is very extensive. One fun fact that we have is that you should not turn on all the catalogs because it will take a while and the actual sky chart will be completely covered. But we give you that data. If you see on the right where the sky chart is, you can see all the LBNs and LDNs, the bright nebulae, linked bright nebulae and linked dark nebulae. The NGCs are red, and all the annotations like the M104 Sombrero Galaxy, M96, when you search for something in the sky chart, it basically embosses it. So you always see as a quick reference where these targets are. Of course, the red line shows you your limit. I don't image below 30 degrees, so I have a circle around to show me, hey, these targets are available. The purple is a meridian, and the white is zero declination. For the solar system, we can display all the comets, the asteroids, the solar lunar as well, all the information. The comet and asteroids, they can be downloaded directly and compiled and displayed into Prism. The asteroids are in excess of 750,000 asteroids, and the comets, there are a few of them as well. And the solar and lunar the data is also available. To the right of the screen, you should see a display of how the moon is going to be in the next few days, all the way to July 29th. This could be done with one click. The satellite TLE data is also a direct download, compile, and display. You don't need to be seeking data online. You don't need to be going to the MPC to find the data. We download it with one link, compile it, and it's immediately displayed in the sky chart. This is very, very powerful. The menu here to your right, to the top right, is a contextual menu anytime you double click on an object in the sky chart. For this one, I picked a star plus an exoplanet. It's an exotic item. So these pieces of information will change depending on what you click on. If you go onto a linked bright nebula, it will show you a scale from 1 to 6 of how bright it is, and so on. So it's very contextual, and it's very dependent on the actual target. You can then slew to the target, you can synchronize on it, you can download a DSS image of that to see what it looks like. Maybe it's a great nebula that you want to immediately slew to and start imaging. Same thing for the satellites. We can actually plot satellites around the trajectories if you're into satellites, and asteroids and comets are displayed as well. Hardware control. Prism controls the majority of the hardware that has drivers, namely ASCOM compliant. We also support some native DLLs that's inside Prism, namely Apogee, FLI, Optec, SBIG, QSI, and so forth. So what does it support as a whole in categories? So we support CCD and CMOS as well as Canon DSLRs. For Nikon, we don't have support yet, but that's something that is on the roadmap. We support mounts. Any mount that has an ASCOM driver, we support. Yes, we support software BISC mounts through the SkyX because of the ASCOM driver. I use 2 of them myself, an ME2 and a Mighty. We support filter wheels. These could be 2 of them. We support focusers, rotators, your dome, your roll-off roof, your weather station, cloud watchers, your power switches. This is very powerful. We can actually turn on and turn off power in automation at the beginning of the end of your session. This is very powerful if you're running on batteries, for example. We have systems in Chile that are on batteries and you don't want your system to be running all day. We can power up and resume. GPS receivers as well. As a new implementation as a few days ago, Prism will actually control the Perseus 4-port selector. So if you have multiple instruments on the back of your telescope and you want something to control it, Prism can. And a big news as well is we support Prism will be installed on Prima Luce's Eagle PCs directly, which means we will dynamically control their ports as well, namely the dew heaters and the power in them. This version will be coming out, so it is to be announced. So Prism will be installed directly inside and controls everything that the Prima Luce Eagle PCs have to offer.
Hamza, I have a couple questions before you move on.
Sure.
Could you go back to your sky chart? I'm sorry, didn't want. So can you zoom in and show the frame of the CCD, and if you have the off-axis guider and the rotator position?
So we do, and unfortunately I can't zoom in on it because, let me see, you know what? Let me see.
Can you use your windows? There we go.
So this is here, your field of view indicator, and it will allow you to make a second CCD. If you have a dual imaging system, for example, an RC and a refractor, you can draw both FOV indicators in there. And for something like an SBIG, the guide chip is immediately displayed automatically.
Can you adjust the position of the guide chip relative to the main chip?
You absolutely can. The offsets are available, and so are the focal lengths.
Okay.
And the rotation. You can rotate it any direction you want.
And do you have actually any imagery that you can see on here?
I'm sorry, any imagery?
Yes, actual images of the object.
I'm sorry, I'm not following.
I'm
sorry,
go ahead,
if you're
Eric.
doing the elephant trunk, it'd be nice to see a picture of the elephant trunk overlaid on top. I've seen that on some sky charts. Does this allow you to do that?
Yes, it does. Not only do we draw the major nebulae in here, they're drawn. When you zoom in on the sky chart, you'll actually see the nebulae laid out. You'll recognize them from their shapes. We'll also allow you to download those regions from the Deep Sky survey, and you can download and embed them in the sky chart.
Oh, and there's a question here over on YouTube. Does Prism use the same plate solve catalogs as SGP?
I'm not sure, to be honest. So all these catalogs you see here, we can use to plate solve. So the GSC, the USNO, the UCAC 234, all these can be used to plate solve.
Those look, Hamza, like the catalogs of that looks like the standard names of the catalogs.
Correct.
But are all those drawn on your screen for the plate, or no? Or does your plate solver compare your image to each of those catalogs, or whichever ones you choose?
It's whichever catalog you choose to plate solve with. So if you decided to plate solve with Gaia DR2, you can. That's extreme precision for some applications. So the sky chart does not display all these catalogs because you will saturate immediately.
Okay.
But when you zoom in, as you zoom in, you can actually establish a level of zoom for each catalog to be displayed.
Okay. There's a disconnect in my brain. There's a difference in my brain between a guide star, or between a star catalog and a plate solving catalog. A plate solving catalog is an index of shapes in the sky that has to be matched to the shapes that are determined in the picture.
Correct.
Whereas a star catalog is just a list of stars with their locations. A plate solver does not actually use the locations. A plate solver uses the patterns of what it has detected.
That's correct. This is all dependent on the engine and what it uses to plate solve.
Okay.
Prism, for example, could use the GSC ACT catalog you see in front of you, or the USN or the USCAC. It doesn't matter. If the information is available, you can plate solve an image very, very fast and very successfully, actually.
Okay.
I have one more question about the display. Can you set the level of star brightness and like the LBN brightness as well, and turn things on and off so you don't saturate your field of view with objects?
Yes, absolutely you can. All these catalogs can be turned on and off. We have sorting options inside the sky chart. You can sort by magnitude, or you can sort by size. So you will only display, say, if your field of view of your telescope is 2 degrees, you can limit the entire sky chart and everything in it to 2 degrees.
I think that's all for now. Thanks.
No problem.
And there's nothing over in Rumble Talk. So it's back to you, Hamza.
Excellent. Thank you. So focusing. We offer focusing as well. There are multiple methods offered. We can manually focus. You can grab a star. You can open the tool and click on a star and focus on it. This could be done using a star centroid, the conventional focusing, or you can do FFT focus. You can manually focus on craters, sunspots, planets. This is a very, very effective way to focus. It's very, very sharp. And sometimes it defeats the eyeball. This is very, very good. We have automatic focus that produces V-curves, as you see on the right. The top left tool is the automatic focus. So Prism will calculate the critical focus zone automatically for you, because if you see at the bottom, there's the focal length of the telescope, the diameter, and the pixel size. You can optimize the step size. For example, we prefer to use 13 steps to focus. This gives us enough on each side of perfect focus to draw the V-curve. You can also choose your own steps and your own step size if you wish. You can decide on the profiles on the left. For example, you can establish profiles for winter and summer for people that do not want to mess with temperature compensation. Direct focus in Prism will find an appropriate star brightness for you. For example, without the 16-inch f3.8 we have, I'd like to focus on a star between 10 magnitude and 13th magnitude with an exposure of 2 seconds. This is automatically for you. Prism will find it within the radius where you're at, will slew to it, center it, plate solve, and start an autofocus run. This is what our automation uses, or the automatic observation. You can always use this very reliably for automation night after night. I focus every 30 minutes because of the size of the telescope, and every time the star is found adequate, never saturates, and it's perfect focus. You can focus on spectral lines if you wish, as you see on the bottom right. This is very, very efficient for people with spectrographs, as this allows very, very good sharpness. This is another image with the same telescope that I wanted to share with you. This is the Antenna Galaxy, or NGC 4038. This is from Chile. Again, it's beautiful, very tack sharp, and again, Prism was used to even collimate the telescope, which I'll talk about in a little bit. Autoguiding. For longer exposures, we offer a few methods. You can use a star centroid, and we give you the freedom to use what's the minimum motion to trigger a correction, what's the maximum motion that we should use as well. You can set the aggressiveness for both RA and DEC, and you can set up the minimum ADU for star detection above the background. If you're particular about that, you could do that. 500 ADUs, 1,000 ADUs above the background. We have automatic DEC recovery. What this is a very smart algorithm inside that will look at your DEC drift and actually compensate in the opposite direction. This is especially problematic when the polar alignment is not great and you're imaging, you set your guider, you do a meridian flip, and now on the other side, you start doubling up the corrections, or the errors start doubling up instead of correcting. So Prism will always look at 2 or 3 or 4 or 5 exposures, establish a trend, and react to that. This is very powerful for people that have problems with DEC guiding. You can see the tool on the left side, the bottom of the left side. So you can have the controls where you can set your aggressiveness, you can set your minimum motion. The DEC has its own tab at the bottom where you can set all the parameters to make sure it's never drifting. Calculations offers an RMS value, which is the true guiding quality anytime the graph turns red. When it turns red, as you can see, green then red, that means an exposure has started. We do not care if it's guiding, there's no exposures being made, or if there is dithering. We're only calculate the RMS value of when an actual exposure is being taken. You can adjust the displays of these graphs, and you can use sharp lock. This was included with Prism for a while now, but since Dr. Gaston Boda decided to take it as its own thing, and I do believe it's called SkyGuard now, we are reworking the integration with his software to offer you that capacity as well to integrate through API. After my conversation with Dr. Boda at NIAC this year, this would be a huge addition so that people can take advantage from his pioneering systems. On the right side, you should see the actual graphs of guiding, the conventional graphs. The RA corrections are in blue and the actual errors are in red. So here you could see if your system is overcompensated or not. We can use also centroid guiding on one star, or you can use FFT guiding on multiple stars, moon, craters, sunspots, planets. Yes, you can guide on a crater if you wish. FFT guiding is very powerful. It can use a section of your image, or you can set the whole image. So if you have multiple stars in an image, you can use the complete frame to guide on all those stars. We have slick guiding as well for people that need it. Adaptive optics are also supported. And like I said, Innovation Foresight's SkyGuard. And this is to be announced when integration is complete. Are there any questions so far?
Yes, Hamza, I have a question. Focusing on a surface like solar or lunar, how exactly does that work? I know that was a slide or two before.
What it does is, it's called FFT intercorrelation. What it does is the developers calculated the frequencies inside the image. And with this calculation, he can deduce which way to move the focuser to actually get the sharpest image possible. There's no actual feature that's required in that image. This is especially useful when you have multiple stars. So you can use the same to guide on all of them on the entire frame. So FFT intercorrelation is what's used in the background for this to happen.
And do you support video captures?
Absolutely, we do. You can actually guide with a video camera. If you have, say, a QHY or ZWO with a direct show driver, you can actually guide very high frame rate with a video camera. Absolutely, very good question.
Okay, thank you.
I've got another question.
Absolutely.
What are the typical resources required on the PC hosting Prism?
Excellent question. Not very much. From what I remember, you can. I have a customer that's actually installed Prism on a stick, on these new stick PCs. You wouldn't believe you would even open a program of any sort, and Prism runs on it no problem. So we have a setting inside Prism that can lower the how intensive the calculations are. So this can run on a hard drive that has as little as 10 gigs of free space and 500 megs of RAM. Again, I thank you for the question. The computer we have in Chile, at Deep Sky Chile, actually has a Celeron. This is a 7-year-old endless computer with about 8 gigs of RAM, and we managed to operate Prism no problem every single night. That's what drives our telescope down there.
Is that for image acquisition purposes only, or can it handle all its processing and analysis and everything else happily with that?
Well, it depends how long your web breaks at work are. It depends how long you're willing to wait. For really heavy lifting, say, extract 40,000 stars from an image or look for an asteroid, naturally, it's not going to be ideal. You want a robust computer that can have enough RAM and enough resources available for Prism to really crunch the data. For acquisition, it's more than adequate to have a Celeron with 6 or 8 gigs of RAM.
Okay, so it's basically like any other set of programs that if you that we can get by with what we're operating on our little laptops or something like that. But when it comes time to really processing, we're going to want a nice monitor and a faster computer and all that other stuff.
Absolutely. And that, again, a great question. We have a 32-bit version of Prism for capture, and we have a 64-bit version for heavy lifting. This can use as much RAM as you throw at it. I use an MSI laptop for my processing, and it will take as much RAM as you give it. The 32-bit version can do everything. But as you know, I'm sorry, go ahead.
Before we get into some of the other questions that are over, I managed to log onto the YouTube screen, and not much is happening over in Rumble Talk. So just checking these out. Some of these questions might be better held until you've gone through what you plan to present, and some of them may be answered in the course of that. You're around what, 14? How much other stuff do you have in this overview right now? Should we wait?
I have a lot of goodies. I'm going all the way to 26 to 28.
26 to 28. Okay. Some of the questions, and just put them off if you're going to be answering them later.
Okay.
How does Prism manage declination backlash? from Linda.
Okay.
And
Yeah,
is that a now or a later question?
I can answer that now.
Okay.
We have settings in declination that you can set. You can actually set the amount of pixels, how much should we push back, how much should we wait for it to catch up, and so on. So backlash compensation is actually in the deck settings.
Okay. And Steve Baldwin wants to know, could you mention which functions of this program, Light, Advanced, Pro, etc., are which functions are covered in which level?
Well, that's a session to itself, to be honest. I will direct to my website where I have a version comparison.
Okay.
It's really well laid out.
Okay, why don't we wait till we get to the end of the prepared program, and then we can touch over there. Maybe you can pull up a website or something.
Absolutely, it'd be my pleasure.
Okay.
Very good question.
Okay.
This
I
just
think that's it for the questions then.
right. Just to highlight a quick point. This session is supposed to be an overview over Prism as globally. So everything that's in Prism, we're gonna gloss over it. So there are no specifics about one variant or another. So we will touch on that at the end.
Okay, proceed.
All right, thank you. So this sums up Autoguiding. I have a video tutorial about this, and I'm due to do one that's very, very well detailed about how Autoguiding should work for all systems. So I will make an even more extensive video about this coming up. Plate solving. So we plate solve, as we discussed earlier. We have a few methods here. We have a local, quick 5-degree radius plate solve. If you have really good pointing and your scope is good, you could, or after you just synced, you could just plate solve really quick, as you can see on the image of M33 in the back. We can actually show you. One quick question. Alex, can you see my mouse?
Yes, we can see your mouse. And I want to remind you, Hamza, and anybody that's listening, we are paying attention, but we mute our microphones when we're not talking. And it sometimes takes us a while to grab the mouse, unmute, and get back to you.
Absolutely.
Yes, I can see your little mouse clicking around. Actually, there it is right there. It's right in the middle of the white space.
Excellent, excellent.
Okay.
Now I can really point at things.
Okay.
So the image in the back is my own M33 image. I plate solved it. So to show you what it looks like, the green are all the stars that were identified, and these numbers below are the residual errors from those stars. We can even establish which way is north and which way is east, and we can deduce from that which way is south and which way is west. This is great when you're trying to look at an image and look at a sky chart to orient yourself to know which part is which. Quick tip, we have an automatic function that will even automatically mirror your image and any images coming out of your camera to mimic the sky chart. So it looks north up, east to the left. So it'll automatically flip all your images. Prism has a native all sky plate solve as well. This is can search in all the visible sky in case you're a little bit far or you can't plate solve. We also support astronomy.net online. This is really convenient when you really need a robust engine to plate solve something for you. And as of late, we support directly the astronomy.net local engine, and it's directly controlled by Prism. And this window here is what that control panel is. You have control over the engine. It's not like it used to be where you throw an image at it and see what it does. You can actually set up the binning level of the image should be submitted to the engine. The sigma with regards to the noise, the background noise, you can limit the search to 5 degrees if you want it quick. You can even adjust the array and deck coordinates, which we get from the image from the FITS headers. You can use your image size, your pixel scale, and you can time out. This is very important. Sometimes it takes it a while because it's searching all over the sky. You don't want to be waiting for 10 minutes. You can time it out at a maximum of, say, 60 seconds. To the right, this here, I wanted to show you what the plate solving does in the background. When you plate solve an image, this panel comes up. We can even calculate the curvature of your field based on the actual stars. All these are stars that are used for plate solving, and the red ones were rejected. We allow you to use what degree of the polynomial you want to use. If you want to use 1, 2, 3, 4, 5, it's up to you. And at the bottom here is all the positions of the stars and all the residual errors if you want this level of detail in plate solving. Moving on. Polar alignment. Of course, we have polar alignment. So we have two quick ways to do this. We have the conventional drift alignment. You slew your telescope to the south, you let it drift, you make an adjustment, you're done with that. You go east or west, you do an adjustment, you drift, you do an adjustment, go back and forth. This is supported in Prism as well. We also have a unique feature called the King drift method. And the King drift method goes exactly the opposite of the conventional drift method. And we go above the celestial pole, north to south. And it's very simple, it's very easy. So the operation goes as follows. You slew your telescope above the celestial pole, and you trying to be as close to the meridian as possible. You take an image, like this image on the right. Well, naturally, first of all, you open the tool, then you take an image, and you click on a star. You click this, add measurement, click on the star. Then you wait for a little bit. If you see here, I waited for the first one, let's see, about 6 minutes. So between my first measurement and my second measurement, I waited 6 minutes and 43 seconds. Took an image again and clicked on this button, add a measurement, and clicked on the same star. And I said, hey, it didn't move enough. Prism said, hey, the error is too big. You need to wait a little more. So I waited another 6 minutes. So a total of 12 minutes and 6 seconds. And I took an image, clicked on this button, and clicked on the same star. Prism said the measurement was okay. And the entire error that I had was 2.4 arc minutes from the pole. So basically what it does here, it draws a vector on your image. And what you do, you go to your telescope and you don't slew to that point. You actually go to the telescope and you start looping the image as Prism takes images. And you move that star from this position to this position. And that's it. If you polar align again, it will take a long time because this tool requires 4 pixels of drift to establish which way the mount should go to be perfectly polar aligned. The advantages of this tool is that it's not affected by anything from refraction to see into anything, because if you take a 5-second exposure, it'll negate the majority of the problems. And it's all calculated anyway. So in 12 minutes of time, and before it was completely dark, I actually polar aligned my telescope remotely with the assistance of my local host. And it was 30 arc seconds from the pole. And the entire operation lasted 12 minutes to find the vector of motion to where what I needed to put the star to be perfectly polar aligned. I tried this myself with an AVX, a Celestron AVX, and an Explore Scientific 102. This is extremely fast. So if you start before it's dark and you can manage to see a star, you can be polar aligned within arc seconds from the celestial pole before it's time to start imaging. This is incredibly powerful and very fast. Any questions?
There are some questions that we've talked about in general about some costs and licensing and things like that. Would you like to take them now?
I will address those at the end.
Okay, keep going then.
Absolutely, thank you. All right, moving on. Automation. There's an automation module that's built into Prism, and it does everything you can think of during the course of a night. You can plan your targets, you can autofocus, and autofocus, you can also establish the star and the magnitude, the distance that it needs to slew to find it, the maximum, the minimum magnitude, the amount of ADUs above the noise to find the star, and Prism will go there and autofocus. You can establish the time it requires. With my 16-inch Newtonians, I typically refocus every 30 minutes. This is dead on every time, and the focus is beautiful. Very, very sharp stars. We can control your roof or your dome, open and close, and open and close the slit or the roof itself. In Prism, this is asked a lot. Yes, Prism actually handles weather events. What it does, it will actually close the slit or close your roof and wait for the cloud watcher to declare safe again. This is very powerful. Nothing is turned off. You just close the roof and park the mount and wait. So Prism will try multiple nights over the night to see and interrogate the cloud watcher to see if it's clear again. So we don't just close everything when the cloud passes by and then you lose 8 hours of clear night right after that. So we control how the files are handled. You can drop them directly onto your desktop, your computer. You can drop them into Dropbox, or we can send them through FTP, through secure SFTP for you. You have that option as well. Plate solving naturally is handled. In case of the local plate solving failure, we can actually send your image to astrometry.net, and that could be online or to the local engine. This is very powerful when you don't have very many stars in the image because of high clouds. Typically, the astrometry.net engine is very, very powerful at plate solving that. Flats, we can do your sky flats, or we can do a flat panel. A recent addition is we execute scripts before and after flats. This is very powerful as well because myself, I need to park them out and face my light panel, and then I can execute a script in Prism directly to turn on the flat panel. I can adjust the brightness as I wish, and I can take my flats, and then right after the flats are taken, I can set the altitude of the sun where it should be so we can take flats. I can set the altitude, the maximum where I should stop and close everything down. You can set the filters and their bidding in any configuration you want. And Prism will actually automatically adjust the exposure up and down to match the right ADU level for your camera. Prism will know the characteristics of your chip and will actually adjust the exposure to get the best flats possible for you. And at the end of the flat sequence, you can turn off your flat panel. If you're using sky flats, you can actually calculate the exposures as the sky is getting brighter or darker. This is absolutely excellent if you want to go straight into the sky and target the null zone and take your images. Startup sequence, we has an entire sequence from synchronizing the mount to cooling down the camera to even powering up. I use a digital loggers switch, which has an ASCOM driver. Thank goodness for the developer that developed that. And we can turn on power to the equipment so it's not running all day. You can establish what sequence you turn on the power, what's the wait time, and so on. My filter wheel, I need to wait for 2 minutes after it powers up. So I can put a delay in there to wait for it. The shutdown sequence, again, you can target the sun elevation. You can park your mount, warm up your camera. You can establish what the steps to cool down and warm up your camera are, and Prism will do this for you. Park the mount, warm everything up, and you can execute another script if you wish, if you have a special application that you need, just like turning on fans, turning off fans, turning off anything in the observatory that you wish. You can control this with a script, and really the sky's the limit. And finally, we have error management, just in case something goes wrong. You can close the roof, park them out, and you can send an email if you wish. The FTP offload is at the end of the session. You can FTP offload everything from Chile straight into your Arizona PC if you wish at the very end. So any questions about automation?
Yes, there's a question about managing targets and something like a scheduler that you might see in ACP.
So very good question. So Prism in its conception was not designed to have multiple night scheduling. So all the targets you see on the side, what I was doing supernova survey. You can see all the PGCs and NGCs. And Prism has a couple of smarts inside. What it does, it will go and image whichever target is westward first. whichever target is going to set first to maximize imaging time, and then you'll work backwards. But you can force it to use any order you want. If I click this option over here, it'll actually execute them in this order if you don't want the algorithm to kick in. We are developing Prism on a weekly basis, and this is constant. There's no telling what the automation is going to morph into. We're looking at more and more autonomous automation that allows people to do more and more. So I hope that answered your question.
Yes, thank you.
You're welcome. This is a beautiful, beautiful image that I would like you to appreciate. This is NGC 3313, shot by, again, Laurent Michel, and it's absolutely exquisite. Again, you better make good use of your ASI 1600 if you have one. This was taken over multiple nights, a number of hours, and again, you can pre-process in Prism and go to your favorite program and keep post-processing in Photoshop, PixInsight, AstroPixel processor, anything to your heart's content. Pre-processing and some post-processing that we'll talk about later is very, very capable. Calibration frames. Yes, we can take them directly inside. We have the tools here on the right. You can capture your flats, you can capture your biases and your darks. Each tool has different settings in it. For example, for the flats, you can stop this at real tracking. You can add a filter name to the string, and you can add a date. And basically, you can tell Prism to do these. Hey, I want to take 11 flats of luminance between 500 milliseconds or half a second to, say, a maximum exposure of 2000 milliseconds or 2 seconds. And Prism will automatically vary the exposure to get you the best flats possible. Under camera options, you can set up the binning and framing that you want. Maybe you have an ASI 094 with a massive chip and you want to just capture flats for half a frame if you wish, you can do that. Biases and darks are done the same way, whereas for those you can add the temperature to the file name. Over here to the top right, you can automatically calculate the best times in local time and in universal time, if you wish, for your location, for the perfect time to take sky flats for people that really want to take that. And you can take this manually. So we'll just tell you, hey, the best time is 6:26 a.m. And if you feel like doing it manually, you're more than welcome to, you can. This tool in the middle will create your massive biases, darks, and flats automatically and very easily. All you got to do is load them in, and you can load in multiple darks and multiple biases and multiple flats. For example, you can load darks dash 60 seconds, 30 of them, darks dash 300 seconds, 60 of them, and Prism will actually stack them according to their what we call families, file families. All the 60 seconds would be stacked by themselves, all the 300s by themselves. And the same goes for the flats. They will do the luminance, the reds, the greens, and so on, all by themselves. Very convenient, very fast. Background modeling and removal. This is a very, very good tool that I want to talk to you about, and it's great, especially for problems like that exists inside images. Sometimes it's a straight light to the side, it's moon glow, it's what have you. So you can easily model the background with just a few clicks. I have a video tutorial about this on my YouTube channel where I go through this and how to do it. You can then, as if you see at the bottom, this is M33 again. And this is vignetting caused by my corrector. It's just not enough, not big enough. What I did with a few clicks is I actually extracted the model of the gradient from inside the image and extracted it into a separate image by itself. And then I went into the image-to-image math in Prism and subtracted it. And this is the result. It's completely gone. It's completely flat. This is a crude example to show it's dramatized, to show you what it will do. But if you're careful with the settings, you can absolutely extract any gradient from your images. It's a very, very powerful tool. So something to do with this is if you stack your luminance and RGB, for example, you can take the masters and even out the gradient completely out of them, then combine them. This is very useful for light pollution, like I said, for moon gradients, and so on. Optical analysis. We have tools to tell you how crooked your system is. Sometimes one needs to know that to understand why are there stars that are elongated in the corners. Why are all my stars elongated in the same direction? Well, Prism can calculate the optical characteristics of your system with a single click from one image. If you open the M33 from earlier, with one click, you can get all these images, which are the analysis output of the tool. So here to the right, I want to explain to you what I mean by elongation. Well, if a star was perfectly round, I mean, the axes would be exactly the same. So typically, that's almost never the case. So this is the actual deformation or elongation, and we can calculate this in a ratio. So basically, this is the long axis, the minor axis, and this is the angle of elongation right here. So Prism can give you your focus uniformity map, which is this guy over here. And it's color-coded to basically show you the changes in focus uniformity throughout the image. This is the full width half maximum major axis plus the minor axis divided by 2 of all the stars in the field. So basically, as you radiate away from the center, the stars get worse. The elongation angle, this is the plot that shows you a map from the angle of the major axis of the full width half maximum with respect to the x-axis, or this guy over here. So this is basically how the elongation of all the stars is displayed here. And you can play with these settings to exactly match what color coding you want to help you better understand what the deficiencies are in your image. The sig x and sig y times 100, this is the ratio between the major axis of the full width half maximum and the minor axis of, again, the full width half maximum of a star according to its position on the image, which is this image over here. This is, again, useful to see which way your system is tilted. And this could explain why one side of the image looks one way and the other side of the image looks another way. This could be due to tilt. This could be at the chip itself because of manufacturing defects. This could be because of the focuser. This could be because of a multitude of things. Even more powerful, we have a dedicated tool for tip tilt measurement inside your system. And the way we do this is very simple. You basically autofocus on the center of your image. You autofocus just like you would do any other time. You get a V-curve of the center image. That means your actual image is sharp. And then you move with regards to the focal ratio of your system. Say I have an f4 Newtonian. So what we do is we move 30 times f4, which is 120 microns. It's very simple. You input 120 microns in the focuser control window, and you move one time, you take an image. You move another time, take another image. And you do this 3 or 4 times on one side of focus and 3 or 4 times on the other side of focus. Or we have a script that one customer wrote that will do this for you. And what we do with this is that this tool will perform V-curves on all the stars in the image, or up to 500 stars in the image. And then if there was no tilt at all, and there was no curvature at all, and your system is completely flat, completely tilt-free, all your stars will focus at the same location or focuser distance in millimeters. But you'll find that the majority of the time it doesn't. This is indicative of tilt. So you load all these files in this tool and you press OK. And then it will actually output this window. And if you can see, the slope here and the curvature here are measured in millimeters. So not only do we tell you in graphical representation what it looks like, we can actually tell you how far in millimeters your system is off. So you can take your measurement and tilt your system say 0.1 millimeter in one direction to remove tilt. This is incredibly powerful, and the majority of people, or a lot of people, do have tilt problems, and this tool will allow you to know in a known unit, in millimeters, how much of tilt do you have to correct it. Any questions?
You got them, Eric? There you go.
Yes. Hamza, are you going to get to the different versions and their features in comparison?
I was not planning on it because this is an overview of the entirety of Prism, but I will get to it at the end. Absolutely. I will talk about the 3 versions.
And we had one user who used to use Prism but can't get a license anymore. I don't know if you want to deal with that privately.
No, absolutely not, because this is an educational event. I do encourage the user to reach out to me, and we can handle any issues anybody has. No problem.
Okay, thank you.
You're welcome, sir. Moving forward.
Yes, go ahead.
Do you have anything, Alex?
No, you're good. Go ahead now.
All right. All right. Thank you. This is Thor's helmet. One of my favorite targets. This is again shot in narrowband with a 1600 and a 20-inch telescope. This is beautiful. One thing I would like to note here: these people actually used Prism with the tools I just showed you to completely negate any defects in their image. And if you look at this image, corner to corner, there's 0 tilt. These stars are basically all the same shape all across. I wanted to show this so that the users and people watching can have a frame of reference as what a beautiful image should look like. Photometry. This is a little bit more advanced, but believe it or not, a lot of people do photometry. On the right side, I wanted to show you a quick photometry analysis of an asteroid that we shot a few weeks ago. And this image here is, you load a bunch of images, 10, 15 into Prism. You tell it what you're looking for. This is for a known asteroid. This is not for discovery. This is if you want to get a light curve of a known asteroid. And Prism will actually crunch all the data, extract all the stars, pick 3 or 4 stars that are the most stable and use them as references automatically, and then gives you this graphical interpretation of what it found. This is a magnification right here of this area, and this is the asteroid. Through all these images, it actually moved right here. Or it even highlights it and names it for you. Very powerful. This can be done for fixed objects, like a variable star that you know, or an exoplanet transit, very powerful. A moving object, like a comet or asteroid. This tool also extracts this graph over here. And by the way, just like to point out that the majority of these subjects have YouTube tutorials on my channel at Hyperion Astronomy on YouTube. Very detailed. They go through these one at a time. If the people watching want to know more about these, the majority are there. I have 35 YouTube tutorials. This graph will show you the distribution of all the stars. And if you find any sticking out, typically there's something going on. A variable star was discovered with this tool just by clicking on it and watching the light curve. And in fact, it was a variable star. So this is very powerful. You can use the photometry to extract all the stars in the image. This is useful because when you extract all the stars, you can establish what's the maximum depth you can go with your telescope. Say, I want to know what's the dimmest object I can get to with a 5-minute exposure. Well, if you extract all the stars, there is a tool that allows you to know the distribution of the stars per their magnitude, because we use astrometric information from the star catalogs to know their magnitude, and we can measure them in Prism, and that will show you that. You can measure any star you want, and you can also calculate the sky background to see how bright your skies are using this photometry tool. Moving forward. Solar system objects. This is fun. This is fun because it's directly built in. On the right side here, you see the options menu of the sky chart. When you go inside the solar system and the comets, it's over here, you'll find that we can actually find the planets and all the comets you can think of. You can search here and you can display all of them. If you click on an actual comet, we have all the orbital data here of these NEO objects, their speeds and so on. We can even give you the magnitude and elongation curves if you wish to know where these objects are and when they're coming back, because this is useful. And this is done as well for asteroids. So the data is downloaded directly. You don't do anything. The user doesn't do anything. The MPC, the minor planet, or we can download it from the Lowell Observatory. It's downloaded, compiled, and displayed in Prism automatically. The user does nothing. We do all this in the background. You can also build your own database of near-Earth objects, and you can display them in the sky chart if you wish. As an example, comets at the bottom here, again, I'm to the right. You can display your own objects, and you can have your own files with this data to display yourself. This could be discovery data that you would like to display on your own sky chart before confirmation and publication. So you can display all the comets and all the asteroids on the sky chart. Quick note here, I advise against displaying all the asteroids because there are 780,000 of them as of last night. Displaying them in the sky chart on a slow computer might be an exercise in patience. There are a lot of asteroids that we track. So this is where you use the sorting options of the sky chart to make sure that you only limit the magnitude of what's visible. And another use of that is that if you know your telescope is good for magnitude 20.5, you could limit the sky chart because beyond that is not visible to you anyway. So it's a very good way to do that. Any questions so far?
We've got some that are hanging around, but it's probably best if we just finish up your presentation and then we'll go at them. Okay.
Absolutely, let's do that. Near Earth object discovery. So for people like myself that are interested in NEOs, there's a tool in Prism that will actually help you discover a comet or an asteroid very easily. You go around the ecliptic, you take 4 images each, and you keep moving, take 4 images, and then you load them into the tool. And Prism will calculate all the candidates inside based on detection and compares it to the MPC data. You can actually build a report for you that you can send in an email. It's very, very easy. So on the right side here is the tool. You can load your files and you can set the data, and this is extremely repeatable. So night after night, you can load the data in families like we discussed earlier. This could be one target, and you can move again and load another field. You can load 10, 15 fields of 4 images each, and you'll crunch through all of them. Through here, the MPC parameters here, you can input your own observatory data for the MPC reporting. And at the end, when you validate through blinking the candidates, it will actually output an email format that you can just copy and paste and send to the MPC. And a quick note, per a few power users, namely Dylan O'Donnell, asked about the ADS format, ADES new requirement. Yes, that is on the roadmap, and that we will also output in that format. So it's easily recognizable and it's pain-free for the users and for the MPC. I would like to make a quick note here. Ms. Claudine Reynaire, which is an amateur astronomer from a French amateur astronomer and the power user of Prism, discovered 3 comets using this very tool right here from her observatory in France and I believe Morocco. This function is extremely powerful. Her comet, as you see at the bottom here, is called P-2011 W2 Reynaire. And if you're like me and her and a lot of other people, a lot of other hopefuls, and you want your name permanently attached to the night sky, this is a good tool to use to crunch through your data and potentially discover a comet of your own. Telescope modeling. Yes, we do. We have we use what the Professionals use for an equatorial mount, we use two hemispheres, east and west, and whichever one the tube is on. And for alt-as applications, we also have all-sky for alt-as, and it's based on T-point. So it will negate some errors in your system, namely polar alignment, dynamic non-perpendicularity, tube flexures, encoder errors, and it will put them in an east and west side of pair files that Prism can display and use. On the right here, you see the tool that helps compute the pointing model for each side. And when you load the files here and you press compute, so basically all these T-point terms are calculated. As you can see here, mine are not bad. 9.3 arc seconds RMS out of 100 points for one hemisphere is a very good value for a 16-inch Newtonian. And this could be done for a east and west side. And at the end, you can just save these files as a point.core, C-O-R, which what Prism uses. At the bottom here, you see the tool that acquires the actual points in the pointing model. So this, you can use any number of parameters you want, a minimum elevation, maximum and minimum deck, what side of the sky, meridian angles, if you have trees or something blocking your vision. You can establish the hour angle in array gaps, your deck gaps, and the delay if you wish, what catalog to use, the framing, and you'll also display them in the sky chart, as you can see, and you can see the progress as these points turn red when they're plate solved and valid. This is great. This one note here, this could be used potentially for any telescope system out there. You can do this with your telescope. It doesn't have to be a specific telescope. You can load these into Prism to correct for your most common errors. Another note, the higher the quality and the stiffness of your system, the higher the rate of correction from a modeling system like this. So if you have a system with very repeatable issues, they can be negated. But if you have a lot of flexure in your system and it's not great stiffness, inherently you're going to have less correction. This is universal for any modeling system like this. Again, no matter what your system is, you can do the modeling for your telescope and load it into Prism. And I will have a video tutorial about this as well, how you can load these into your version of Prism and correct for these errors of your own telescope. This is the end of this session, which is an overview. So this is where I'm going to take the questions, if you would, from the viewers.
There were questions about the different levels of Prism and what you basically get for each one. And I guess people are going to ask, what do they really need for the average astrophotographer?
Okay, so I apologize again. I made this as an overview without trying to get into the financial side of the software, but I will answer these questions. So there are 3 versions of Prism. There's the light version. This is designed for somebody that's with their telescope trying to take images manually. And
hang on a minute, Hamza. Do you have this chart on your website someplace? Could you just change your screen over to there?
Absolutely. Let me find it real quick.
Take your time and right now we're just looking at something that says questions. But if you've got that chart, it'd be cool.
Absolutely. Give me just a second, please.
I want to remind people, it looks like Rumble Talk. Well, we have, 15 people over there all together. Most of the people that are there, I think, are also over in the YouTube chat area. If you go over to the YouTube chat area, we like that because it keeps a record of all the questions you're asking along the course of the meeting. It also cost us $18 a month less than Rumble Talk, which, like, we like to provide for you guys, but we don't know what Rumble Talk is offering us besides, the $18 a month that YouTube doesn't offer us. Oh, now we're up to 16. But at any rate, so while Hamza is getting ready, what's happening over there, Hamza?
1 second, I'm almost there.
Okay.
Allow me 1 second.
Well, we're seeing your PDF presentation still.
Yes, yes.
Okay, okay.
By design. Good
Ah.
thing I have two screens.
I don't know if you guys have ever noticed it, but when you see my screen, you'll notice that it doesn't have any icons on it to tell me where to go or where my files are or anything like that. And the reason for that is because I once heard somebody say after a presentation, like, am I going to take advice from that guy? Do you see how many icons and everything he's got plastered all over his desktop? How organized can that person be? You know, so I always just hide all my icons. They're there. I just don't let you see how messy a person I am. Huh, Hamza? Isn't that what's happening? There we go.
Here's the version comparison.
Okay.
So the light, the professional, and the advanced version. Some of the main. I'm going to go through this real quick. It's on my website under Prism. If you go there, you'll find this same sheet, but I wanted to go through it real fast. So the light version, like I said, is designed to have one CCD camera and one guider. And this is designed for somebody that's right next to their telescope. They want to take their images manually. And believe it or not, I have customers that would like to do that, even though they have the advanced version. They don't want the automation. They want to sit right next to it and hawk it. Whatever floats your boat, we have it. So if you want that, the light version does that. And I put these nodes here to establish the difference between the three versions. So the advanced version can take two CCD imaging cameras at a time and one guider. The advanced version only can do this.
And when you say CCD, you mean CCD, CMOS, and DSLR, or?
That's correct. That's correct. So any of these, well, I apologize. This is my mistake. So yes, it's any CCD, CMOS, or DSLR, an imaging camera.
Okay, anything that can be connected with ASCOM or FLIS, big QSL.
Or a native driver, absolutely.
Okay.
So the advanced version, you can have two full imaging systems going at the same time. Two main imaging cameras, two filter wheels, two focusers, two telescopes, one mount. The advanced version can do it. The professional version can support one imaging camera and one guide camera, so can the light version.
I'm sorry, it says two there. Did you say one or two?
It's two, so we
Okay.
consider the guide camera as a camera as well. So basically here, two imaging cameras, one imaging camera, one guider, one imaging camera, one guider. And the advanced version is two imaging cameras, one guider.
Oh, okay. So these are the two that you've got there is an imager plus a guider.
That's correct.
Okay. It's not like it can be running two different imaging cameras unless you get the advanced model.
Correct. The advanced version is designed for that. If you have, say, a big RC and a big refractor, you can image with both at the same time. There's a note here. This, as of yet, does not work in an automated manner because it's very complex. We're working on this. It's on our roadmap. But if you would like to set up an actual sequence yourself and launch it, and yes, it will dither both, and yes, one of them will be the main. The first camera will take charge of plate solving and synchronizing. And so the dither will be good for both. The advanced version, which I will go into in the third session, which is, I believe, September 9th. Is that correct?
I would have to check right now.
All right, it's in September. The third one will be there. And these functions are what professionals use in professional observatories. These are available in the advanced version as well. So as you go down this list, you will find a bunch of nodes here in the light version. Naturally, it's lighter. And then there's not a lot of differences between the professional and the advanced version. And yes, we have a way to upgrade from light to professional to advanced. If one wants to go from light directly to advanced, they can. The professional version is designed for complete observatory control and analysis without the dual imaging cameras and the advanced version that are displayed right here. Does this answer that question?
Thank you.
You're welcome. Any other questions that?
Will you show us in later presentation at some time, who was it that they wants to know, do you have a screenshot of the actual imaging session coming up? What does it look like when I'm sitting there taking pictures?
Oh, of the actual system?
Yeah, what's the software's interface look like when I'm actually taking pictures?
Oh, if you would allow me 1 second, please.
If you're going to do it in a later presentation, that's fine too. I just want to know.
Well, I have it, and I can show you. I can try and show you my remote system. So the interface of the system, and this is our own observatory in Chile. This is AnyDesk showing you the actual interface itself. So this is what it looks like when everything is on the screen. It's not connected because it's cloudy and it's asleep, and there's nothing to be seen. And this is the actual sky chart. So this is in Deep Sky Chile. If you go to deepskychile.com, this is where it's at.
Okay.
So the automatic observation is down here. And this is what I was imaging last night, is NGC 300 in RGB.
Okay, cool. If you buy a license of premise, that was, who was it that wanted to ask that? Anyway, Jeremy Taylor wants to know, if you buy a license of Prism, can you use Prism on more than one PC? For example, a remote capture PC and a local heavy lifting PC?
Absolutely.
Processing?
Absolutely. We predicted that question. As you know, a capture PC and a processing PC, a lot of times are not the same. So we offer 3 different activations on 3 different PCs. So the question comes, what if my PC crashes? Well, don't worry. That PC still counts as one activation. Our server is smart enough to know that that's the same PC with a different hard drive, for example. If you run into problems, we're more than willing to work with people. And above all, if somebody say, I have customers that have capture PCs that have Windows 7 that swear to God they will never put internet on it because of safety concerns. If it's a government agency, if it's some sort of a secretive system that cannot be exposed to the outside, we have a thumb drive that has a processor on it. And anytime you plug it into a PC and you turn on Prism, it unlocks it automatically. We have that solution as well.
Yeah. I'm looking through the questions here. I'm going to hold off Paul's question. He's asking about what type of camera you would recommend for use of this, but I'm going to hold that off because I'm afraid that's a really big discussion. James Grubb wants to know, does the telescope modeling work to change the tracking rate of the mount or just the pointing?
That is an excellent question. That is very, 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 very mount specific. Here's why. If we establish the pointing models and load them into Prism, like I will explain in the video, well, Prism can actually offset the rates of, say, a comet, say, an asteroid. But if the driver of your mount does not allow for differential tracking, then no, you cannot. Say the SkyX that I use because of the ME2 and the Mighty that we have in the Arizona observatory. Well, you can set those directly in the SkyX. But the Nova 120, which uses Prism as a backend, you can offset the tracking rate directly. So it's mount dependent and driver dependent.
Okay. Okay. And I think that might take more answering specifically. And I would suggest Paul, who was it, James, that you might want to directly contact Hamza. And I think you can find the information on the website.
Absolutely, please do.
Yeah, because I'm not sure that it can be answered well enough. It needs more specifics and stuff. I'm going to skip Paul too there for a minute because it's a bigger question. Terry, no, Steve Baldwin, is the tilt function you showed part of the CCD camera characterization? Is that advanced only?
No, it's not. That's available in the professional version as well.
Okay, and what's going to happen when version 11 comes out to the licenses?
The licenses are more than likely going to have a different price structure. However, for the people that purchase Prism already, there will be a heavily discounted price to upgrade.
So you pay a little bit extra and you get the new version.
Absolutely.
Okay, but that hasn't been decided. Do you know when that might be coming out?
No, absolutely not. We are working on it, and we're going to go in heavy development here soon. It's going to take a quick turn.
All the information's on that little thumb drive, and it doesn't ever go out to the internet, right?
Absolutely. See, you
Okay.
figured it out.
Okay. Paul's easy question is, I have SGP already, and is there any discount to purchase Prism if purchased through TAIC? TAIC doesn't exist as far as purchasing anything for it, so I don't, are you offering any special discounts or anything else, or is that something we should go to the website for information about?
Look, I love TAIC, and I've been on it more than a few times, and this is why Prism is on sale right now for 10% off on all versions right now.
Okay. And back to Paul's earlier question, for image processing, do you recommend one-shot color, CCD, or CMOS cameras to get the most out of Prism?
Ooh, that's a tricky one. So it depends. Most out of Prism. Let's say you want to take advantage of all the analytical power of Prism. Well, one would argue that a monochrome cameras is better. But if your interest is cosmetic imaging, say, just quick and easy imaging, I would go with a one-shot color, absolutely. We have an ASI 094, beautiful chip, beautiful camera, and imaging with it with an FSQ 106 is beautiful. You can take full advantage of Prism either way you go.
So the software can handle any of them. It all gets back to the good old argument about which is better, one-shot color, DSLR, LRGB, CCD, CMOS, and that's a battle that will rage forever.
Oh, yeah.
Yeah. So,
but it has one easy answer. It's fundamental and always true. It's whatever makes you happy.
That's true. But it's fun to listen to them argue for the first 150 or so posts.
You saw it on cloudy nights. There's a lot of popcorn in there.
Yeah. How many folks are currently using Prism? John at Astra wants to know.
Thousands.
1,000 or so?
Very good question. Very good question. We have some very high-end people using Prism. In the next few months and in the near future, you're going to see that number increase dramatically. And since we were going to the AIC, NIF, we have more and more government agencies, more and more special projects approach us about Prism. Why? Because of the power it packs. It's an incredible value if you think about it. And above all, it's easy to use. Once you get people say, well, I'm going to have to get used to this again. Well, you had to get used to everything else you have.
Mm-hmm.
That is not an argument. You have gone used to whatever you have anyway.
Okay. Tell the people about AIC for a second or two.
As in?
What's AIC? What is not the AIC, but the real AIC?
Oh, AIC is an astroimaging conference, and NIAC.
Hello.
I'm
Hello.
here.
Can you hear me?
Can you hear me? Hello.
I've lost sound.
Hey, Eric, can you hear me? Terry?
I can hear you. Can you hear me?
Yeah, I can hear you. I think.
Okay.
Alex.
I can hear you.
Are you
I'm
back,
sorry.
Alex?
I'm sorry. I lost audio for a bit. Why don't I butt out and you tell us about AIC?
Well, I mean, AIC is an astroimaging conference that's going to be in Santa Clara in September of this year. It's for advanced imaging. And we went to the NEAC, which is the Northeastern Astroimaging Conference, and that's when I met you, Alex, if my memory is correct.
That's
And
right.
that's for the both revolve, East Coast and West Coast, both revolve in advanced imaging. And you will more than likely find a lot of the high-end mounts, CCD, CMOS manufacturers in there.
Mhm. And Eric will be there if you want to meet Eric. And Tolga will be there if you want to meet Tolga. I'll be doing a presentation about Sequence Generator Pro. My book about Sequence Generator Pro should be out by then. I'm getting the proofs next couple of weeks from now.
Excellent.
So we will be doing, I will be doing a presentation about Sequence Generator Pro. And so there'll be lots of stuff to see. It's November 17th. And I got to tell you that the Advanced Imaging Conference is pretty advanced. They are trying to appeal to some beginners and stuff like that, which is probably why they invited me. But it's quite a show. Okay.
Absolutely. I've never been there, but I heard great things about it.
Yeah. Space Ghost asks, is it over? What are we talking about? Is what over? Is the presentation about, are there other questions about Prism, about Hamza's presentation? Hamza, what are you going to do next month and the month after that?
So next month we'll talk more in depth about planning, capture, automation, and processing. And in September, we'll shift gears and we'll talk about all the most advanced functions in Prism.
Okay. Now, earlier you said that some versions of the software for the people who want to sit there next to their computer and stuff like that. In fact, if I have my Type VNC connected to my computer in the back, and the computer in the observatory in the backyard is running Prism, I can control my Prism session from my desktop computer here inside the family room, right?
Yep. Yes, you
Yeah. Okay. So when you say for those who like to be sitting there, they could be sitting there, or they could be sitting there, and there is in Chile, and they're sitting here back in Arizona or someplace.
Absolutely. Good point.
Okay.
Absolutely.
Okay.
I was thinking more of people in the field, because typically that's what I used to do.
Mm-hmm. Okay. If there are any more questions, you best get them in quick, folks, because we're about to sign off. Thanks, Hamza, for bringing that in. I remind you that although it says July 7th is when you're supposed to have your workshop processing in, go ahead and get it in now if you haven't gotten it in, and if you've been doing some image processing on that stuff on Terry's data. So get that stuff in, and otherwise, I think we got them all, Eric, don't we? Oh no, Steve Baldwin snuck one in.
I've got a question as well.
Is it download only, or is there a CD DVD option?
That's a good question. For now, it's download only, but we're thinking about going for USB as well, physical USB that we will load with a Prism copy and the majority of the star catalogs, and something we can ship in the mail for somebody that wants to have that.
Okay. Then we're going to sign off for the Astro Imaging channel tonight. I'm glad you all came. I hope you enjoyed it. Remember all our old shows, some 255, 60 of them. Remember also that if you have something that you would like to present, you don't need to be an imaging professional, whatever that is. You don't need to be, you need to have something that contributes to something people might want to know about astro imaging. So if you've got any of that stuff, please contact me either on Cloudy Nights. My name's Alex McConaughey over on Cloudy Nights, and come on over and we'll try to get you on somehow or another. And
I wanted to add something before we check out.
Sure, go ahead.
I wanted to introduce my website, which I poured my soul into, trying to make it as beautiful as possible.
Okay.
If you see on top is hyperion-astronomy.com, and this is the website. This is the front page. You're going to find Prism here. You're going to find some testimonials. You're going to find some images. And if you go under Prism, it has its own tab on top. If you can see my mouse up here. So if you go up here, you're going to find a definition of, hey, what's in the advanced functions, if you want to look at them, what they are. And you can go and read the testimonials, publications. There was a publication about Prism in Astronomy Technology Today by Mark Zasloff, a great article that's already there. And if you go and click on Prism itself, I built this page as a landing page to kind of shorten the questions about why and how and so on. And this page will run you through it. All the images you see here were captured and pre-processed with Prism. The majority were processed with Photoshop. These are some of the names out there that are using Prism as far as institutions, some testimonials, and pricing.
Okay, so I take it that you're a general astronomy retailer, and one of the retail products that you have is Prism.
I created the company solely to take care of Prism worldwide. Absolutely.
Okay.
That was my initial takeoff point. And then we picked up, the things that we like, Optec, some all-sky cameras and CN monitors that the developer of Prism actually sells.
Okay, cool. Well then, folks, I think it's time to sign off.
Thank you very much for having me today.
Thank you for being here.
All questions, please reach out.
Yes.
Thank you very much. Have a good evening.
Bye, everybody.
Take care.